So, given the following definitions for simple connected graphs, Kn is a graph on n vertices where each pair of vertices is connected by an edge. So that is essentially what we call a complete graph. And just a quick look at a complete graph there. Every pair of vertices, let's say we have 4 vertices there, 1, 2, 3, and 4. They are all connected to each other. So we say each possible pair is connected to each other. So that is a complete graph. Now, Cn is the graph with vertices v1 and so on, where the v1 is connected to v2, v2 is connected to v3, so on. V3 is connected to v4, and the last one is connected back to vn. So we call this a cycle graph or a circle graph. Okay, we'll call it a cycle graph, and that would look like this. So let's say we have 5 vertices, 1, 2, 3, 4, and 5, and essentially the idea of a cycle graph is that they are all connected to like they're connected in the chain going back to the first one there, like that. So that is that we call that C5. That one over there we call K4. Wn is a graph obtained from Cn by adding an extra vertex, Vn plus 1, and the edges are connected to all of the vertices of the original. So let's have a look at that one there again. So 1, 2, 3, 4, 5, and they were connected like that. Or let's put that in red. Let's put it in magenta actually. So 1, 2, 3, 4, 5. Now what has happened here is that an extra vertex is to be added. So let's put the extra vertex right in the middle. And the idea is there's edges from this extra vertex going back to all of the original vertices in C5. So essentially what we have here is what is more or less a spokes of a wheel, so to speak. So that's how we might draw it there. And that there we call that W5. Just remember it refers to having 5 vertices and then a 6th vertex added to it. So it's n plus 1, but it's still W5 even though it has 6 vertices. Right, that is that part there. Now that's not the full question. Okay, draw K4, K4, C4 and W4. I've drawn K4 already, so I'll just draw C4 here. It's a very quick exercise. 1, 2, 3, and 4. So 1, 2, 3, 4. That's C4. Cycle graph. And we'll draw K4, W4 as well. And again, it has 5 vertices. Watch out for that. By the definition, it'll have 5 vertices. 1, 2, 3, 4, and 5. And let's put that in there. And yeah, and again, they are connected up. The fifth one, the last one, is connected up to the original 4. So it looked like that. Now, giving your answer in terms of n, write down an expression for the number of edges in each. Okay, well, Kn is there's n vertices, and the degree of each vertex is n minus 1 degree. So, for example, if there was They're connected to each of the other vertices. So there's n minus 1 other vertices. So multiplying them out and dividing that by 2, n times n minus 1 over 2 is the number of is the expression for the number of edges. So just remember, edges get counted twice in when you're talking about the degree sequence. An edge gets counted twice from the point of view of one vertex and from the point of view of the other. So that's why you have to divide by 2. Let's do it for C4 now. Let's do this one in red. Cn even. So there's n vertices again, and the degree sequence of each is 2. So, and again, what we're dealing with is n times 2 divided by 2, and that's just equal to n. The degree of each vertex is 2, and again, each edge gets counted. You're counting an edge twice that way, so you have to divide by 2. So it just ends up as n. Okay, and for Wn, let's do this one here in green. So we have there's two parts to it here. So we have C4 or Cn, which will have n vertices, and then you have another vertex, the extra vertex, and it's connected to the original ones. So it would have degree of extra vertex is also n. So you actually have n plus n, and that is equal to 2. Okay. So, and in this case, we're only counting the extra ones, the extra edges once. Okay. They're not. We're looking at it in the context of, first off, the C4 part, and then from the point of view of the extra vertices, the extra edges from the extra vertex. So anyway, that is types of graphs. That's 2007 graph theory.